In this video, we're going to start with the basics. Specifically, we're going to look at the International System of Units, or also called SI units. Now, this should be a review from your high school and your prerequisite courses. And you'd think that this is common knowledge in the discipline. And it is. And all electrical engineers, well, almost all electrical engineers, follow these standards, system of units. However, from time to time, mix-ups do happen when different teams working on the same project, well, when they end up using different systems of measurement, disasters happen. Now, that's one of the things that we want to stress in this course very, very strongly, is that units matter. Okay, you really have to pay attention to the units that you are using in this course. Now, if you want a very popular example, okay, here is a high profile example on how NASA lost its multi-million dollar probe, Mars probe, in 1999 just because of a mix-up, mismatch between units that two different teams are using. Okay, so there's a YouTube link. You can click on that and follow what exactly happened there. So we are going to define the units very specifically that we are going to use in this course. Okay, so let's define them. We are going to follow what is called the International System of Units, or SI units. Okay, so SI units, and these tables are taken from the textbook, they have a set of what are known as fundamental quantities, or defined units. These units quantify fundamental quantities like length in meters, mass in kilogram, time in second, electric current in ampere, okay, and temperature in Kelvin, amount of substance, that's in mole, and of course luminous intensity in candela. Okay, and the symbols for those units are provided here, and these are all from the textbook, right? Now, so that's about the defined units. Now, in addition to these defined units, and these are the ones that we will be using, these are the standards units that we will be using in this course. Now, in addition to these fundamental quantities and defined units, we also use derived units. Okay, that are derived off of the fundamental units, or other derived units. Okay, so frequency, as you know, is always the standard unit is hertz in SI system, and the force in newtons. Energy or work is the unit is joule. Power is in watts. Electric charge, coulomb. Potential is in volts, right? And then electrical resistance, the units for that is ohms. Conductance, which is the inverse of resistance, it's in Siemens. Okay, and of course, capacitance is in farad, magnetic flux is in Weber, and inductance is in Henry. Okay, so these are the derived units, and there's simply go through this. This should be mostly a review. There's no rocket science in here. Just get familiar with these. Okay, and then in the coming problems, what we will see is to look at some problems, how to convert from different units into the standard SI system as far as our course is concerned. Okay, then let's look at this. There are powers of 10 that are very, very important. Okay, why do we need powers of 10? Well, we deal with quantities that are extremely large or extremely small. So we need quantities that have a range several orders of magnitude. Okay, so I'm an extremely large number ranging to an extremely small number and everything in between. And that's the reason why we like to use powers of 10 to denote the amount of fundamental quantities. Okay, the ones that are most important that we end up using most frequently are nano, micro, and milli in this course, of course. Okay, and of course, kilo and mega are the most frequently used powers of 10. Milli is 10 to the negative 3, micro is 10 to the negative 6, nano is 10 to the negative 9, kilo is 10 cubed, and then mega is 10 to the 6. And these are the most frequently used powers of 10 in this course.